Okay, in this video we're going to see how to utilize the extension RS from RresLib to pack and unpack or game assets and resources. So they're not public available and they're single pack in one file that only you will have access to it. So in order to do that, we go to RresLib's website. We scroll down onto our res, we click on it, and that will take us to the GitHub page on which we can download the release version, which is 1.0.0 and corresponds to the version 4.2 from RresLib. There's a slight chance that if you clone the code directly from the GitHub, something might be broken because they're working constantly on it, and there should be a problem or something they removed, and that can be used to RresLib 4.2. So to be safe, we're going to get the RS version 1.0.0. So we'll click on it, and we get the source code. Once we get it, we open it, we click on the source folder, and we're going to need all these three things: the two header files and the folder called external, which has another files inside of it. So in order to test what we're going to do with RS and see how it works, we're going to create a new project. I already have it set up on Visual Studio. You can utilize whatever you want. I already have the minimal working project for RresLib, which I can compile. When it works, then I can test it, and works without a problem. So this is a minimal window I'm using, just showing the text with a frame per second doing, and everything goes fine. RS is written in C, plain C, and I'm using C++. So there's probably some things that I need to fix or to do in order to make it work properly with C++. But we're gonna see what's about it. So we start by extracting the contents of the source file from RS into the project folder. We just paste it here, which is the easiest thing. Then we go back to the Visual Studio project, and we can add a file which will be in charge, will hold the implementation from RS. We call it res.c. I have to do it in C. Okay, once we create the file res.c, we're going to include the file so it can hold the implementation and compile it once. And for that, we're going to do the next thing. We need to include RresLib. Then we need to define the implementation for RS, and then include the header file RS. Next, we need to define now the rres-raylib implementation to let him know that we're going to use RS with RresLib. Then we need to include the header file rres-raylib.h. So we close it, save it, and then we need to compile it, and we have an error. So we go to check, and there's a bunch of warnings that throws Visual Studio. And for you to know, Visual Studio is really picky when it comes to some things that you use in C++ and when it comes to C. Now here we see an error call from some obsolete functions and unsafe functions, which is the error C4996. Now here's the deal. Visual Studio is really picky about it, but we know this is working fine. This library, this extension from Raylib. And this problem is because by default Visual Studio is enabling the check for unsafe or obsolete functions and marking them as errors. So the best thing to do will be to correct or modify the rres.h and rres-raylib.h file in order to avoid those problems. But it's gonna take a lot. So the best thing and fast thing to do here, which I don't recommend to do it, but we will do it this time because we know it works and this program is safe. We're going to disable these errors for Visual Studio. And to do that, we need to write pragma warning disable colon 4996. Save, compile, and it works. So we already have the implementation file of RS working, and we need to include it into the main file. So with this included, I try to compile the solution, and okay, compiles, no errors, no problems. So we start to do some things, and in order to get this working, we need a file made for RS to use, and for that we go to the Raylib page, click on the RresPacker tool, and this is the online version. You can see I already purchased it. So in order to do this, we can drag and drop the files here, and I already have the assets ready to go. I have a texture, a font texture, sound effects, and a background music. So I select those, drop it here, and that's it. We see options here, which is cipher password, which is the password you can use to encrypt the access of the file. We leave it by default, password 1, 2, 3, 4, 5. The compression you can select individually for each of the file, which is none, deflate, LZ4, QoI, and encryption type, which is the AES, XChacha20, and none. In this case, we're gonna leave everything by default and none, and that's it. We build it, we give it a name, click and save it. Then we copy the file, put it into the project, and we're ready to open it. So we're going to start by loading the texture from the file. So we need a texture, 2D. Just remember, we are using C++ to make this. You can do it in C2. You will have less problems than I, but you can follow up as well. Now, as we create a texture, we need to unload it to be safe. And then what we need to do is we need to load what is called a central directory, which is opening the file and get the kind of the beginning of the file. So we do that by creating a new variable called res-central-dir, call it dir, and we load it using these commands: rs load central directory. We pass in the name of the file, resources.rs, and then we can unload it. There you go, because everything will happen here, so we don't need to wait until the end of the loop to close it, because we're going to load the data and put it into the corresponding variables, which is the texture, sound, etc. After this, we need to get the ID from the resource inside the file. So we do that by creating an int variable. We're going to call it ID text, and we get it by calling the function res-get-resource-id. We pass in the central directory we got a few moments ago, and we get the file as if we were loading the file name from the folder. In this case, it's called awesome.png. Next, we need to load the resource chunk, and we do it with the resource chunk variable. Call it chunk text. Resource chunk. We pass in the file name, and we pass then the ID from the chunk. Then we proceed to load to the texture, and in order to do it, we need to load the resource chunk to an image and then upload the data from the image to the texture. Sounds complicated, but it's easy, believe me, trust me. We pass in the resource chunk, and then we upload the data to the texture. Call the function load texture from image, and then we don't need the image anymore because all the data is already in the GPU, so we can unload the data to avoid any memory leak. And then we can unload the data from the resource chunk. Call it in 50/50 in white. Save it. We check that now we don't miss anything. We already unload the texture, we unload the image, we unload the resource chunk, we unload the central directory. Everything should work fine. So let's see. We compile and we get error. Let's see the list of errors. Okay, external symbol, shock image, load image from resource, unresolved. So the problem is on RS. Okay, as I stated before, as RresRaylib and RS are made for C, and we're using CPP, there are some special conditions that need to be included into the header files. In this case, this guard is missing here in the RresRaylib implementation. So what we need to do here in this part which says module function declaration is to type the following. Def, okay, C++, extern C, okay, ndif. And here, before the ndif for the implementation of RresRaylib, we do the same. And we close the bracket here. We save it, and this should work. So we test it again, compile, and there you go. Successfully compiled. And now we need to test if the texture is loaded correctly and is being drawn correctly into the window. So we open the program, and there you go. We're going to do the sound next. So we need a sound variable. Okay, we do the same. We unload it. We don't need to call load central directory twice because we already have the variable here, so we can use it. What we do have to do is to get another ID from the resource. In this case, I'm going to name it ID sound unloaded. And this file was called fx.ogg. Load texture from the source file. And here, and then load sound on resource file. Okay, and we do the same. We already got the ID. We need now a chunk called chunk sound. Load it from the file, resource file, remember, and using the ID from the sound. And to load the sound is almost the same as the image. We need to load the data to a wave, then upload the wave to the sound file, and we can proceed to unload the data from the wave and the chunk. We do that next. Load the wave, then the sound. Then we discard the data from the wave. And we unload the data from the chunk, so we don't have any memory leak. Okay, we do here, and to avoid this one to be played every 60 frames per second, we're going to put a conditional here. Every time we press the space key, the sound will be played. Play sound. Okay, we compile, and compiles fine. Now there's some issue here that I haven't talked about it, but it will cause a problem here. So you're gonna see what problem it is, and I tell you what is the solution. So we open the window, the program, and we hit the space, and nothing. But then we see here in the console window there's a problem. Failed to get a frame count from a conversion and the data conversion pipeline. So we close it, and you could be confused here that probably the sound is the problem is the data from the sound or the loaded data from the chunk, but it's not. The problem here is we didn't initialize the sound device, the audio device. We do it here, we close it, we try it again, and it should work properly. Okay, no errors, which is good. Hit space. Okay, working. Perfect. Good. Okay, we close it. And we go for the next thing, which is the font texture. We do it by creating a font here. Create a font. We unload the font. Okay, and we load it here. As we're loading a font as a texture, we're going to load. We need to get the ID, of course. Font. Load. Okay, source ID. Put there. The file name was font.png. Okay, we get the chunk font. Okay. We pass in the ID for the font, and then we load it to the font. Font, we'll call load font from image. Sending function here. And for the parameters, it needs an image, which we have here. Color, which is the color that is going to be the transparent one. In this case, we check the texture file, which is the magenta one, which is the ugliest of the colors. And the first character. For the character is asking for an int, a number. So the first character that we have, and we know it starts with the ASCII letters, is the space, which is the number 32. So we put here number 32. Do it and then download the image. Okay. Then we download the chunk. Chunk font. And we're ready to go. So next we draw something with that, we draw some text with that new font. Draw text. X. So we can select the font. The font, the text is hello new font. Res is awesome. We pass in a vector. Okay, 30. Font size, we call the base size. Spacing 1 pixel, and color we put it white, gray white, just for a change. Okay, if everything goes fine, this should work. We already download the font, the chunk, so we compile fine, and test. Good. Then we have the font pack into a file with all of the rest, the sound, the texture, the font. Perfect, it's working. Now for the last part, we're going to get we're going to load background music and load it as streaming audio streaming. And in order to do it, as the past one, we need a variable, which is a music. We unload the music stream. Okay. Now to load it, we need to do something different to the file. As we put in here as a file audio, we need to mark it as raw. Why? Because it's an MP3, but for some other reason, if you check the file, it's 44 megabytes, which is a lot considering our 4 files only are 3.17 megabytes. So in order to fix this, for the MP3, we're gonna check where it says raw. So it's gonna pack the raw format file to the packed file. We build it again. We call it resource rs, and we see the file size has changed. Now it's 3.5 megabytes and not 43.4 megabytes. So we replace it. Now we check that everything is not broken here. Everything is working fine here. Okay, we have the texture, font, and the sound. Okay. Now, in order to do this, we need to load the raw data to an array and then pass that data from the array to the music. But the problem here is that this is audio stream. We can't unload the loaded data from the chunk until we are done using the streaming asset. Why? Because if we unload the data, then as the program is streaming all the data, it will find 0 bytes and it won't play anything. Follow me on this and you will see. So we create a holder for the data, and it requires a void pointer. We initialize it, and then to free this data, we need to call a function called memFree. We pass in the pointer. That should work. Okay. Okay. Now we'll load the background music. Load the streaming audio, write data on the resource file, and we start the same with an ID background music. Call it rs load resource chunk. Okay, we write the resource file, resources. Okay, we pass the ID. Okay, 1, 2, 3. Need to load the ID from the resource. Call ID BGM background music. Get resource ID. Press there, and the file is called music.mp3. Then we need to get the chunk. Pass in the ID BGM, and then what we need to do is to load the data from this chunk to this array. We need a variable to hold the data size. Then we load it, and we use the function load data from resource. We pass in the chunk and the address of the data size variable, so I can write it down. And a good safe check here will be to check if the data size value is larger than 0. I'm gonna omit here just for make the video faster. So then we proceed to load the music. But music stream from memory. Does a function call. We pass in. We need to specify which file type it is. In this case, as is an MP3. So we need to. We need 4 bytes, which is the dot file, and then the 3-letter file type extension. In this case, MP3. Don't use caps here. And then we pass in the pointer to the data, cast to an unsigned car, pointer, data, and then we pass in the data size. Okay, and that's it. If everything went fine, we need to here and the data and the music file are being unloaded down here. Now we should be listening the background music playing. We need to use this function. And here we need to update it. Update audio stream. Sorry, just update music stream with music. Okay. And we set music volume 3.5 float. And we'll play it. Okay. We compile. Okay, everything compiles correctly. And now the big part, we need to see if it works. Nice. We have a background music, a texture font, and a sound. Perfect. Now, what happens if we unload the data from the data pointer once we load the data for the music? Okay, let's try it. Let's just remove here. We put it here. Data, okay. If we follow the logic for the rest of the files, the data should be uploaded to the music file and then play from there. If it does correct, then the music should be playing. And we get a crash. Okay, this is due because the data is holding all the information from the music stream, and the music is being played as a stream, not as a whole like a sound effects, but as a music stream. So it's loading chunks of it, and is linked to the data file, to the data variable. So if we free that data, the pointer gets set to null, and when we start to play it and update it here, it tries to read a non-existent location, and that's why we get a crash. So don't forget about it. It's important. You're gonna use music stream with a RresPacker. Just make sure to unload both at the same time and at the end, or once you stop using it. In order to make sure this is true, we put everything as it was before. We compile and test. Perfect, it works. So this is all for now, guys. I hope you enjoyed my video as much as I enjoyed making it for you. Don't forget to subscribe, and if you like it, hit the like button. And please give a big thanks to Ray to create an awesome game library, which is rres-raylib, and some extensions, which is including RRes. So see you till next time.